So which of the following can be used as a solvent in SN2 reaction? Do you remember in SN2 reaction, which was the solvent we use? Especially mentioned which one is the a good solvent for SN2 reaction. Okay, at least I'll give an option. Tell me. So polar protic, polar aprotic. So why do we use the polar aprotic? Okay, so what happens here? Polar protic, that means alcohols, water, certain acids. They will be able to make the hydrogen bonds. So when they make the hydrogen bonds, what we'll say? It is soluble in the solvent. So when it is soluble in the solvent, the SN2 reaction will increase or decrease. So when the molecule that we are using, okay, if it is participating in the SN2 reaction, so it could able to make the hydrogen bonds with the polar protic. Yes or no? So when it is making the hydrogen bonds, it becomes soluble in solvent. So what happens if it is soluble in the solvent? The SN2 reaction will decrease. If we use the aprotic, then what happens? It will be present like a naked. It doesn't involve in the bond formation, hydrogen bond formation. So we'll be having more and more nucleophiles and alkyl groups so that it will be very favorable for the SN2 reaction to happen. So which one option could be here out of A, B, C, D? So this is protic, this is protic, this is protic, this is aprotic. So remember ammonia, ethanol, acetic acid, these all are having OH groups and hydrogens here. So they could make the hydrogen bonds. When it could make hydrogen bonds, they become soluble. When they are soluble, what happens? The SN2 reaction decreases. So it is not favorable. So we need option D. Understood? Is that clear? So here option D is a polar aprotic. As it is a polar aprotic, it will be insoluble in water. It cannot make hydrogen bonds. As it cannot make hydrogen bonds, this will be the best one for nucleophilic substitution reaction because it can provide naked and more reactive. Understood? Is this clear for everyone?
Yes, sir.
Yes, sir.
What is the order of reactivity? Does the tertiary is more reactive or primary? Primary is more reactive. So primary is more reactive. So tell me which one will be the answer here. So 1 bromo 3 methyl butane, 2 bromo 3 methyl butane, and 2 bromo 2 methyl butane. What is the order here?
So 1 bromo 3 methyl butane is first.
What is the second?
Is it like 2 bromo 3 methyl butane? And then the last one is
Yeah.
third.
Correct. So this will be 1 and 2 and 3. Nice. What about this? Very simple one, this one. So what is meaning of this? R3, R2. That's nothing but carbon. If it is bind to 3R, we call it as R3. Carbon bind to only 2R and remaining with hydrogen. Carbon only with 1R. So which one is primary, secondary, and tertiary?
Sir, option B is correct.
Yes, this is correct. So here, this one is the primary, secondary, tertiary. And we know the reactive order is primary is more reactive compared to secondary and compared to tertiary. And tell me, why does tertiary is least reactive?
So, due to steric hindrance.
Yes. So this is a bulky group where it will be sliding the molecule where we are attacking. So steric hindrance. Okay, next one. So Rx plus KCN, Rx plus AgCN. What happens here? So what does the KCN molecule will break? K plus Cn minus. And AgCN? Okay, tell me at least this reaction. What happened here? So I broke the bond K plus Cn minus. So now what happens? What is nucleophilic substitution means? So will Cn will go and attach to R or K will attach to R? So K will go and attach to R. So what is this reaction called as? So tell me, Are Srikar, you only tell me. You said na. So tell me, what is this reaction? What we are talking about this reaction?
Is it nucleophilic?
Nucleophilic. So what is nucleophilic? Positive or negative? A nucleophile is a positive or negative?
Negative.
It is a negative. So in this, K is negative or Cn is negative?
Cn is negative.
But you are saying K will go and attach to the R.
Yes.
Come on, guys. So KCN, it will go and break into K plus Cn minus. Here our nucleophile is Cn minus. So this nucleophile will be substituting the allosine. So whatever the Rx is there, so that Rx will turn out to be like this. So there will be bond breakers between the R and X, and there is a bond formation will happen between the R and Cn as it is a nucleophile and result in formation of RCN plus X minus. Understood? So this reaction is called as nucleophilic substitution reaction. So what is the product formed here? RCN. Simple one, very basic one. Tell me about this. So RX, Srikar, you tell. AgCN. So how does this reaction will proceed?
I guess the same. Because Ag is plus, Cn is minus.
Okay. I told you something special about Cn. Do you remember? C triple bond N.
It can attach from both the sides.
Both the sides. Okay. So C minus and N. But actually, so what's happening here? The nitrogen will go and attach. So remember this. So Rx AgCN, here N will go and directly attach to the R plus X minus. Okay. Can someone tell me? Okay. So tell me this.
So will it be RNO2 plus KX?
Nope. See, here the KNO2 dissociate like K plus NO2. Or you can say it's like a ONO. We know nitrogen can make a triple bond. So it will make double bond with one oxygen and single bond with one oxygen. So there will be minus on this oxygen. Okay. So someone can bind here. So what happens now? There is a negative charge here. So this negative charge now can able to attack. So tell me what will be the product now it will form. So in this we got a one electrophile and one nucleophile. So which one is nucleophile and which one will replace now out of Rx? So there is a bond breakage will happen with X and there is a bond formation will happen. So here K will attach or ONO will attach?
Why not?
Yeah, it's a ONO. So the final product that will be formed is RONO plus X minus. Understood? Okay, tell me about this one. Ag and O2. Same happens here. Between the how the K has broken, the same way Ag also will break here. So tell me what will be the product will be formed here.
RONO plus X minus.
Yeah. So next one, tell me this.
Sure.
Yeah.
Sir, in the not in the previous question, the question before that,
This one.
the KCN and AGCN question. So in this first one, it is like the nucleophile it will attach as CN and the AGCN is attached as NC. How do we figure out whether it's attached through the nitrogen side or the carbon side?
See what happens here. There is a triple bond with the carbon and nitrogen. And we know, I said the carbon will be having, see, the main motor for here N to it. See, for the main motor here to release the X and to replace with someone, what is the main motto? So what we call here, it should be a strong nucleophile. So when we say someone is strong nucleophile, see what's happening in this reaction. What is this reaction is called as nucleophilic substitution. Yes or no? Here one nucleophile is substituting the other nucleophile. Here the other nucleophile is X minus, that is fluorine, chlorine, bromine, iodine. Okay. So these halogens, they are replaced with a, I said one word, we use it. See, in the beginning itself, I told you when SN1, SN2 reaction, I use one word. Yeah. You see here. So constant, yeah, you see here, when nucleophilicity increases, what happened? The rate of SN2 increases. Yes or no? And see here, so they are highly reactive, but when they undergo protonation, so what's happening here in this condition? You take carbon and nitrogen, which one is having more, you can say which one is having more number of electrons is the nitrogen compared to the carbon in this reaction. So nitrogen is having lone pair of electrons more compared to the carbon. Okay, so tell me what is the atomic number for carbon? 6, right?
So,
How do you write?
Yes,
1s2, 2s2, 2p2. So you see here. So there is a like this. So all the 4 are involving. There is no lone pair for the carbon. Carbon doesn't have any lone pair. And you take nitrogen. The nitrogen is having 7. Atomic number for nitrogen is how much? Guys, what is the atomic number for
7.
nitrogen? Yeah. 1s2, 2s2, 2p, 3. So this is like this. So there are one lone pair is present, and here each one is having 1, 1, 1. So that's why nitrogen is forming 3 bonds here. Whereas the carbon, it is not having any lone pair. And we said the one which is very having good number of electrons, we call it as a strong nucleophile. Here, nitrogen is having lone pair, and the one who is having lone pair of electrons is the rich guy. Yes or no? So compared to carbon, nitrogen is more carrying more electron density. So that's why this group will go and attack compared to carbon. Understood?
So,
Is that clear?
so then why for the KCN reaction carbon attaches?
Where here?
Yes, sir. You told the carbon will attach to the. So in the first reaction, you mentioned carbon will attach to the methyl.
1 second, guys. Okay, I'll just tell you this later. So I need to see whether the bond is forming between the carbon and nitrogen or carbon and carbon. Sorry. Here R and C or R and N. I need to once check with that. Okay.
Okay.
Yeah. So tell me this. Hello. Ciprofloxacin is not available. Okay. Ask him if there is any azithromycin eye drops are present. Azithromycin. Sir, if come on, guys, tell me this. So the reaction will be fastest in which one? So which one will be the solvent? Yeah. Ethanol, methanol, water. These all can be protic solvents. See, you don't need to know what is aprotic. At least you know what are protic solvents. It's very easy for finding out the protic solvents, the one which can make the hydrogen bonds here. Water can easily make, alcohol can easily make. Remember, alcohol, water, these are protic solvents. Okay. So which one is aprotic here?
Dimethyl formula.
Yeah. If you don't know what are aprotic solvents, at least know what are protic solvents and go with the option whichever it is left. So next one. So tell me what happens here. These are all SN2 reactions. So which one will leave here? Br will leave. And which one will attach? Out of NaOH, Na plus, OH minus.
OH
Yeah.
was attached.
So when I write, be careful. The how you will write. So whether you may write like this, that will be wrong. You should write in the opposite direction. Understood why I wrote this one instead of the other way? So what happens in the SN2 reaction? The configuration will be inverted. Because whatever the nucleophile is there, it will be attacking from the backside. So that's why OH I'm writing here, not on the direction where the bromine is left. Next one. So tell me this. Okay, I didn't tell you about this. See, in this condition, what are the alpha carbons? What are meaning of alpha carbons? The one which is directly attached to halosine. So these are all alpha carbons. The next one, we call it as the beta. So this is beta. Okay. Now check with the beta. So which one will be having more endurance? Which one will be having more steric endurance here? So tell me about the what about the option A? You see here the beta carbon in this, there is it is a quaternary. Yes or no? So will it be having more entrance effect or less entrance effect?
More.
More. So this will be not my option. So what about this?
So
So
option B.
will it be having?
SN.
This will be our option. Okay. Okay, let's keep this aside. So it is not having any, it's a primary carbon. So it's not having any entrance. This is also having bulky group. So it will be having more entrance. Between option B and C, which one should we choose? It is having secondary. Here it is having primary. So it's not the option C, it's option B. Understood? Why I'm going option B, not the option C? We studied primary is more compared to secondary is more compared to tertiary. If the alpha carbon, if all are same, then you go with the beta carbon. If the beta carbon is also same, then you go with the other delta carbons. Okay. Okay. Now tell me about this. Come on, guys. We studied only one thing in this.
Steric
Leave about the
hindrance.
inductive effect, insolubility, instability.
Steric hindrance.
Yeah. So tertiary alkyl halides are partially inert to substitution by what? By steric hindrance. So next one. So one of the leaving, following the best leaving group. So what's the option for halogens? What's the order for halogen? It should be the big one or should be the small one? What is the order? Out of fluorine, chlorine, bromine, iodine, which one is the good carrier of the negative charge?
Iodine.
Srikar, which one?
No, sir. Is it C or D?
C or D?
Chlorine.
I told you. So whenever there is a bond breaking between the alkyl group and the halogen, so the halogen is taking the negative charge with it. It is taking the electrons. And I told you, when it is small, it cannot fit the electrons in it. So it will become a very reactive. On the other direction, if the atom is very big, it can able to accommodate the electrons and it can stabilize the negative charge. So the stronger the stabilization of the negative charge, it will be the good SN2 reaction.
Iodine.
So which one will be the option here?
Iodine.
Iodine. So remember, the reactivity order will be like this. Iodine is more, then bromine is more, then which one will be? Fluorine or chlorine?
Chlorine.
Chlorine, and then
Fluorine.
fluorine. Understood? What is the name for SN1 reaction? It is called as unimolecular nucleophilic substitution reaction. So from this, what you can say here, if it is a unimolecular substitution reaction, so from this, what you can say? We said 2, SN2 is a bimolecular. So what is meaning of here? 1 means unimolecular. So from this, what you can define as? Come on, someone tell me. So what you can define, what you can inference here? If it is SN1 unimolecular, so from this, what you can state? So I said 2 means 2 species were involved. Here it's only 1. Okay, guys, I'll explain. So, okay, listen. So SN1, it is called as unimolecular substitution reaction because if you see in SN2, there is an alkyl group where it is breaking the bond with the halosine. At the same time, the other one is forming the bond here. It could be OH or it could be some other nucleophile. So both the substrates, one is the adding, the other one is leaving. So both are happening simultaneously. So we call it as bimolecular nucleophilic substitution. But here it doesn't happen like that. Only one substrate, one species will involve. Okay, so that's why it is called as unimolecular substitution reaction. So if you see the SN1 reaction, here the nucleophile replaces leaving group. Okay, as if we see SN2 reaction, it involved in the 2 steps. But here it involved in the 1 step. SN2 involved only 1 step, whereas in SN1 you will be having 2 steps, 2-step process. Okay, so that is, one is the formation of the carbocation. Second, attack of nucleophile. So it involves in 2 steps. Whereas there, so formation of the carbocation and attack of nucleophile happened simultaneously. So it is 1 step. Whereas here, both the steps will happen separately. So that's why it is called as 2-step reaction. Okay, so you can see here, first one, formation of the carbocation. First, suppose you see here CH3, CBr. Let's take other carbon. In presence of water. So this will turn out to be CH3, CH3, CH3 positive plus Br minus. So if you see here, when you keep the water molecule, the bond between the alkyl group and the halosine will break. And after breaking that, it will turn out to be a positive charge. So we call this as the carbocation. So this is said to be carbocation. So that's why this reaction named it as formation of carbocation, the first step. So whatever the bond between the carbon and bromine, it will break and that will turn out to be carbocation. So whatever the electrons present here, it will move towards the bromine. So that's how it will get the negative charge. Okay, and remember, this reaction will happen very, very, very slowly. Remember, this happens very slowly. So as it is happening very slowly, so you can call this step as rate determining step. That means it will define whether the reaction will happen slow or fast. So this is a rate determining step or rate determined step. Understood? So understood what happens in the first step of the SN1 reaction. So there is a formation of the carbocation. So how does the carbocation happens? When water molecule comes close to the carbon, it will break the bond with the bromine. So the bromine will leave carrying the electrons with it. So it will be negative charge and we'll be getting the carbocation where the carbon is holding the positive charge. Understood? Then the second reaction, this is called as the nucleophilic attack. So we know nucleophile means it's a negatively charged. Okay. So what happens here is, so whatever the carbocation is there, it will be attacked with the nucleophile in this step. Whereas in SN2 reaction, both the carbocation formation and nucleophile, both will happen simultaneously. Whereas here, it doesn't happen simultaneously. So this is the positive charge. And we know oxygen, this oxygen will go and attack here. Okay, so when it go and attack here, it will form an intermediate molecule like this, where the oxygen now will be having the positive charge. But if you see here, this is very unstable molecule. You can see here, because the oxygen is having 3 bonds. So it is very, very unstable. So you can see this one is a very unstable. So when we know it is unstable, what happened? There is a bond breakage will happen between the hydrogen and oxygen. So that will be liberating as CS3, C, CS3. So whatever the electrons present in this, it will go to the oxygen. And this hydrogen will leave as a H plus. So this H plus can bind with the bromine and it will turn out to be the HBr, and this will turn out to be CS3, C, CS3, OH. Understood? So this will be your final product. So this is the second step. And remember, this step will happen very fastly. Okay. So before step, it is a very slow. So it is called as the rate determining step. And this is a very fast step. So it's a nucleophilic attack because of its instability. So this reaction will happen so quickly. You understood what is meaning of SN1 reaction? So from this, you can state the two differences between the SN1 and SN2. So SN2, it will only involve one step process, whereas here it is a two-step process. Yes or no? And here in SN1, there is a steric, in SN2, there is a steric hindrance. But in SN1, you don't see that steric hindrance. You can see here, it's a happening in the terrestrial. So remember, the formation of the carbocation is very favorable when it is a tertiary carbon, but it is opposite in the SN2 reaction. If it is a tertiary carbon, it is very least reactive. We saw that. So next one. So rate of alkyl halide, first step must be the slow and rate determining step because it is very slow. So it can change the reaction rate or whether it's happening very fast or very slow. So all this will determine this. Okay. So remember factors affecting the SN1 reaction. So one is nature of alkyl halides, nature of the nucleophile, nature of the solvent, and leaving group ability. So all these we have seen. So how does they change? So you can see here the first one, nature of alkyl halides. So in SN1 reactivity, it is very different compared to the SN2. So if you see here, the CS3X, it is least reactive compared to the primary alkyl halide, compared to the secondary, compared to the tertiary. So here tertiary is very fast reactive compared to the CS3X. Whereas this order for SN2, it is reverse. So CS3X is more reactive compared to the primary, compared to the secondary, compared to the tertiary. So remember the notice the difference between the SN1 and SN2. Understood? So you can also see the example for bromine. So when it is attached to 3 carbons, then the reactive rate is almost 12 lakhs times faster. If you see the same one with hydrogen attached, it will be just 11 times faster. And if you see the third, it is almost 0. We saw in primary, it is the most reactive, and tertiary, it is the least reactive or almost non-reactive for SN2 reaction. Whereas here, for SN1, it's so many times faster. And if you see the primary, it's almost 0. So that's the first difference between those two. So tell me, what will be the answer here? So what will be the option? Which one is tertiary here? So this one is primary, secondary, tertiary, and this is 0. So which one will be the option? Is it option
D.
A or D?
D.
Yeah, it is option D. See this one?
Option B.
Option?
B.
Yes. So tell me, what is this option?
So can
Is
I
it of which carbon? See, this C is directly attached to only one carbon. So this you can take it as the primary. Here, the alkyl group directly attached with the X. And what about this? This carbon attached to 2 other carbons. And here, this carbon is also attached to 2 different carbons. Sorry, bromine. So which one will be the best one here? Option B.
B?
So next one is nature of nucleophile. Remember here, the rate of SN1 reaction is unaffected by concentration of nucleophile. We have seen for SN2 reaction, the concentration of nucleophile and nucleophilicity is very, very important. But here it is not at all affected. Okay, so it's an independent of concentration of nucleophile. And to be here, the weaker neutral one, weak and neutral. There we saw negatively charged and strong nucleophile, but here opposite, weak and neutral nucleophiles are favorable for the SN1 reaction. Remember this, the opposite. So it should be the weak and it should be neutral. Whereas in SN2, it should be negatively charged. Negatively charged is more reactive compared to the neutral one, and strong nucleophile is favorable for the SN2 reaction. Okay. And remember, what is the solvent we are looking for the SN2 reaction? Protic or aprotic is favorable?
For SN2, it's aprotic.
So SN2 favorable for aprotic solvent. Whereas in SN1, protic solvent is very favorable. Remember the other difference. So this is one difference, this is another difference. Okay, so SN1 is more soluble in the protic, so it will be called as the solvolysis reaction as well, as it is soluble in the solvent. Okay, so this solvolysis can happen 2 ways. One is it is soluble in the water, or it can be soluble in the ethanol. So we said for SN2 reaction is favorable when it is not soluble in water or when it is not soluble in the alcohol. But here It is soluble in water, is favorable, soluble in ethanol, it is favorable. And this is called as hydrolysis. And this is called as ethanolysis. So what happens in terms of ethanol? The bond breakage will happen. So that's why it is called as lysis. Lysis means breakdown of the bond. And so that they can now make the hydrogen bonds. In presence of water, they cleavage into the ions and they can make the hydrogen bonds. So that's why water is very helpful for forming the reaction. Understood? And you can see the nature of solvent, why it is very helpful. You can see. So using polar protic solvent increases rate of carbocation formation of an alkyl halide. And we know if it is very favorable for the carbocation formation, it will be helpful for SN1 reaction. Yes or no? So they will be having ability to form the cations and anions. You can see here, this is the cation and anion. Okay. So what's happening here when you are using the protic solvents like water or alcohol? So when you use the protic solvents like water or alcohol, so that will be very favorable for the SN1 reaction. And this is happening because, so whatever the solvents you are using, they are very good at surrounding with the negative ions or surrounding with the positive ions. For suppose in case of it's an anion, it is surrounded with the positive ions. In case of it's a positive, it is surrounded with the negative ions, negatively charged. Okay, so that's how they can handle this whenever the bond breakage will happen between the alkyl halide. We know whenever the bond breakage between the alkyl halide, it will turn out to be R plus X minus, and these are most reactive. In order to neutralize them, in order to stabilize their charges, they have to be surrounded with the negative charges if it's a positive charge. They have to be surrounded with the positive charge if it's a negative charge. Okay, so this will be very favorable for the alkyl halide to split. Okay, and to increase the speed of reaction. We saw the first, whatever the reaction, carbocation formation, it's a very slow process. But due to this stability, you can speed up that slow reaction. And that will be very helpful for SN1 reaction. So that's why it is also said as the rate determining step. So based on which solvent you use, the rate can influence and it can make whether the SN1 reaction takes place very favorably or not. Is that clear, guys? So
Yes,
why
sir.
SN1 is very good for protic solvents? So whenever they break the bond, they turn into positive charge, negative charge, and this positive charge is surrounded with the negative ions. That's a O, and making the hydrogen bonds. So they will neutralize the charge. And whatever the negative charge anion is there, it is surrounded with the positive charge. So it will neutralize its charge. So when it is neutralize its charge, it can favorable for more breakage between their bonds. And when it is favorable for more breakage, so it will be favorable for SN1 reaction to takes place. So next one, leaving group ability. So what happens here? Whenever the leaving group, I told you, so it break the bond with the alkyl and it will take the negative charge with it. Yes or no? It will carry the electrons here. So when it carries the electrons here, so it is holding the negative charge and that will be very reactive. So we need to stabilize this. So stabilization is very important here. So this is the one similarity between the SN1 and SN2. The same stabilization is required for the SN2 reaction. The same stabilization is required for SN1 reaction. So can you tell me now which one will be favorable here? So this is the common between the SN1 and SN2. So what will be the reaction? This or this? Which one should I use, A or B?
Iodine will be more reactive.
Yeah, iodine will be more reactive. You understood why leaving group is should be very long, big enough. Okay, why it should be very big? So that it can accommodate the negative charge and it can stabilize the charge. So stabilization is very important. Okay, so stabilization of the leaving group carrying negative charge is very, very important. increases, the rate of reaction increases. Okay, so whenever the stabilization of leaving group carrying negative charge, if it is increases, then the rate of reaction will increase. Okay, so that's about the SN2 SN1 reaction.